Hey everyone, I am Nishakar Kumar and today I shall be presenting a project that I have created on the Algozenith Hackathon 2022. So for this project I have created a MERN stack web application where M stands for Mongoose, E for Express, R for React and N for Node. So this web app constitutes of two components, that is the front end and the back end. So the front end can be found in this client folder and the back end in this server. So let's start the server by first navigating to the server folder, running this command npm run dev. This command can be found in package.json file in the script section, where this command translates to is nodemon index.js, where index.js is the main file's name. So the server has started on localhost port 8000, and also the message is being displayed that the DB connection is successful. The database that has been used in the backend is MongoDB. So since the server has started, let's go to the other terminal and just start our front end. So we first navigate to the client folder and we run this command npm start. This command starts our React application, and for the first time it is going to take a while, so let's wait. And yes, the React application has started on localhost port 3000. So this is the first look of our web application, and so the name of the web app is Algomate, your DSA Companion. So, the web application constitutes of that section which is dedicated to the problem statement of the hackathon. So, let me explain the problem statement that it is that we have to design a search engine so that will go through a big pool of questions, and based on the user's query string, we will get the top 50 results. And it's our motive to make the search engine as accurate as possible. So we will get to that later, but first let's explore the features that I have implemented in this web app. Starting with the user authentication, so this is the sign in sign up page. So the speciality about this page is that there are no two separate pages dedicated for the purpose of sign in and sign up. So in this single page, it enhances the user experience as the user now only has to verify his or her email address. And if the account is not created, the account will first be created and then the user will be redirected to the home page. So let's test it out by entering my email address and we will now generate the OTP. So let's check the mails. And here is the one time password, that is 531199. So let's enter the OTP and click on verify OTP. Yes, we are back to the home page. So now we can go and click on get started. So this is the home page and here is a welcome message. So what the home page basically constitutes of is some brief information about the content that is spread across this web application. So starting with Algomate. So it's just some information about what is Algomate, and then moving on we have some questions of data structures and algorithms, and then again some upcoming events news. Then we have the resources, and finally the testimonials, and at the end, the contact information. So also at the very end, this is the look of the footer. So the footer constitutes of some important links, social links, sources, tags, quick links, about, and contact. So let's explore the next section of this web app, that is the about section. So the about section contains information about me. So here is some information about me and information about my skills and experiences, and finally the contact information. So let's move on to the next section, that is the news. So the news section constitutes of information about the upcoming events and some information about the past computer scientists. And here are a list of websites where the users can go and practice competitive programming. So while this much into the exploration, let me also introduce you to the next feature that I have implemented, which is the dark mode. So you have to click this button over here. And yes, the dark mode has been activated. So let's move on to the next section, that is the resources. So before exploring this page, I would also like to highlight the fact that while in the hackathon, it was also our motive to understand web scraping and Web scraping was what? It was used to generate the big pool of questions which was used in the search engine. So, adding on to the motive, I've also used this knowledge of web scraping to scrape the data of the resources from Code Academy and implement it here. So now the users can go through these resources before attempting the questions. So how to use this resources page is very simple. The user has to just choose any one of the topics out of all these, let's say JavaScript, and choose a subtopic. Let's say dates. So here you will get all the information about the dates in JavaScript with some examples. So let's finally move on to the final section of this web app. That is the ultimate DSA search engine. So here on every page, you are going to find a list of questions and the count is going to be 10. So every page constitutes of 10 questions and that is spread across all these 1265 pages and that sums up to 12,650 questions. And here is also the option to sort the questions by the platform that is Codeforces, CodeChef or LeetCode and also the option to use the search algorithm that you desire that is BM25 or the TF-IDF. Here is also an option to autocorrect. If the user is unsure about his or her spellings, then they can simply enable this autocorrect and the results are going to be the same as expected. So let's test this DSA search engine. So I still remember that while web scraping, I actually scraped almost all the questions of code forces. So let's see if I just randomly pick any one of the questions of code forces and if the search engine is going to able to detect them. So there are around 79 pages, and so let's go to any random page. So here I will generate some random number between 1 to 79, and then we will go to that page. So the random number that is generated is 18. So let's go to the 18th page, and here like I have to just enter the URL, and here 18, and we are here at the 18th page. So let's select a random question here. Let's select this Johnny and his hobbies. So here we are just going to take a random string and what we are going to do is just to make things more challenging, we are going to just shuffle the words in this substring. So here is the shuffle a substring. So this is not going to affect the search algorithm because the search algorithm is based on the keywords and not the order in which they are present. So let's copy this shuffle substring and just to make things more complicated, let's just go and randomly just switch the cases of letters present at different positions of the substring. Here is the final substring and this will be our query string. The question was Johnny and his hobbies and let's see at which position is the search result displayed to us. So let me enter the query string and now we will click on search and the search algorithm that will be used is BM25. So let's click on search. And yes, Johnny and his hobbies is the top result out of 12.5k questions in 0.385 seconds. Just to add on to the user experience, I've also used mark.js, JS library. So what it would do is it would just mark all the words that is in the query string so that the user can easily identify the questions that is well suited for him or her. So let's also test the same result with the TF-IDF approach. And we are again going to click on search. And once again, Johnny and his hobbies is again the top result. And the result was like brought to us in 0.799 seconds. So even after like switching the cases, it doesn't actually affect it because before searching, we are simply lowercasing the substring. And also the as I already said that the order of the words doesn't matter because the algorithm focuses on the keywords only. So this autocorrect is also here. Like even if I just make random spelling errors in these words and then search, the search result might change because the algorithm focus on the exact keywords. So when we enable this autocorrect, it will again fix all those misspellings, and again we will get the same search results as expected. So I have also used some other concepts like lemmatization. So what it would do is that if we just use any random word like adding, so it will just convert it to the add. So it is only going to improve the efficiency of the search engine. So like with this, I think we have come to the end of this exploration of this search engine. You can explore this search engine. I would just add the link of this web application in the bio, and you can just go and test it out. So like moving on to the next feature, and I've also added this voice assistant. So right now the purpose of this voice assistant is nothing but just to search. Like earlier, like we used to search by the search bar with text, and now we can search with our voice. So let's test it out. Let's say I want to search a question about binary tree. So let's say binary tree. Binary tree.
Here are the search results for your question.
And in 0.065 seconds out of 12.5k plus questions, we got the results of binary tree that is the most appropriate. And I think with this, we can conclude our walkthrough. I hope you would have enjoyed it. Thank you. Do visit the web application. Thank you.